Hello. This begins a brief walkthrough of the history that leads up to the atomic theory. When was the atom first thought of? Who first came up with the concept of the atom? Well, we must travel back somewhat in history to 400 BC. A philosopher by the name of Democritus observed the world around him and theorized of the existence of atoms. He predicted that the world around him was all composed of the same small units and called them atomos. He theorized. He did not have any experimental backing. In fact, they did not experiment in those days. However, he was debated openly by Aristotle that firmly believed in and perpetuated the idea that everything in the universe, or everything within their world, they were quite limited in their thinking at that time, of course, was made of some combination or purely earth, wind, fire, water. So the idea of atomos was actually dismissed. Now, we need to take a huge leap in history from Greek time to the Middle Ages. We're going to look at these as the dark ages of science, if you will. So, 1200, 1300, 1400, 1500 AD. Again, kind of the dark ages of science. That is where alchemy reigned. We do not call the individuals who were experimenting chemists. We call them alchemists. They truly were not approaching experimentation in an orderly fashion. They were motivated primarily by greed to be able to find a way to convert everyday substances into gold, and they were not consistently experimenting. They weren't measuring. They were finding some new things in science, but it wasn't what we call experimentation today. Actually, it wasn't until the balance was made widely accessible in approximately the year 1500 AD. And that was mainly to make trade between villagers and different societies, if you will, fair. The widespread access to the balance allowed for consistent measuring. Consistent measuring led to consistent outcome, consistent data, which then increased repeated experimentation, which then led to theories and laws. So, 300 years or so later, the age of experimentation, if you will. So, lab coat and goggles. We want to highlight first, in the progression of the understanding of the atom, the French chemist Antoine Lavoisier. Lavoisier was an avid experimentalist. In fact, it's believed that this is somewhat the device that he utilized to consistently and very precisely measure combustion reactions. What he was able to find was that the mass of his reactants matched the mass of the products time and time and time again. Through this experimental data, Antoine Lavoisier is credited with developing the law of conservation of matter. During this time, and these are the early 1800s, it was the widespread understanding that you could make matter appear and disappear. So he laid the foundation that disputed that. A contemporary of Lavoisier, Joseph Proust, was an avid experimentaler also. He did the work behind the law of definite composition. People, based upon their everyday experience, believed the identity of a compound came from its source and the amount of that compound that you had. So whenever you got a full bucket of water from the village stream, well, that was very different if you got a half bucket of water. Or a full bucket of water from the well was quite different from several drops that you may have gotten from rainfall, based upon their everyday experience. What Joseph Proust said is, no. It's not the source or the size of the compound. What gives the compound its identity is its mass ratio. For example, water. What makes water water is not where you get it or how much you have. It's that the percent by mass in hydrogen is constant in water, and the percent of oxygen by mass is constant. In fact, if we would do the math, it's about 11% hydrogen, 89% oxygen as your mass ratio. So if you would find a compound that had this mass ratio, it could only be, no matter the source or the amount, water. If it didn't have this mass ratio, it would not be water. John Dalton, a contemporary, he was an English chemist and school teacher. He laid a lot of groundwork for advancing chemistry. He was an avid experimentaler, and as far as advancing understanding of the atom, we're going to credit him with two things. One, the law of multiple proportions. He believed, as Democritus did, that there was nothing smaller than an atom. So, when atoms came together to form compounds, there was nothing smaller. So therefore, they combined in whole number ratios. You couldn't add a fraction of one atom or element to another. And he found, upon analysis and experimentation, elements combined in small whole number ratios. So what Proust was saying is the identity of a compound comes through its mass ratio, which is constant, that a compound has a definite composition by mass. What John Dalton was saying was that when elements combine in compounds, they combine in small whole number ratios. In water, we have 2 hydrogens for every 1 oxygen. In hydrogen peroxide, it's 2 hydrogens for every 2 oxygens. Or we could refine it to 1:1. The second thing that we want to credit John Dalton with is combining all the ideas from Democritus up through his work in publishing what is known as the atomic theory. The atomic theory summarized all knowledge about the atom up until the time of Dalton. It was published in 1803. Your book has a nice summary of the atomic theory, as well as the handout that I gave you in class. If you scan over the atomic theory, and this is the handout that you were given in class, it revisits ideas of all the previous gentlemen. Matter is composed of extremely small particles called atoms. That was Democritus. Atoms cannot be subdivided, created, or destroyed. Well, the subdivided was Democritus, which was the continued belief, because they didn't have any evidence to the contrary, of Lavoisier, Proust, and Dalton. But it was Lavoisier that said and proved that matter cannot be created nor destroyed. This is our foundation. This is our foundational, most basic understanding of the atom that we build upon. We need to review this, understanding our basic principles of the atom. We need to have this under control before we can talk about what an atom is made out of, what does it look like, how do they bond, what are the properties of bonding, what about chemical reactions, and so on. This gets us started.